Lesson 11, the ellipse, part 1. An ellipse is the set of all points P moving in a plane such that the sum of their distances from two fixed points F1 and F2 called foci is a constant. The midpoint of the segment connecting the foci is the center of the ellipse. You have figure 9. This is point P moving in a plane. You have the two foci, the center, then we have the vertices V1, V2 on the x-axis, V3, V4 on the y-axis. The points V1, V2, V3 and V4 are called the vertices of the ellipse. The line segment V1, V2, this line segment is called the major axis, while the line segment V3, V4 is called the minor axis. The point O is called the center of the ellipse as stated earlier. It follows that V1, V2 is equal to 2A and V3, V4 equal to 2B. Also, V1, F1 is equal to V2, F2. From the locus conditions, we have F2P plus Pf1 equal to constant. From F2 to P plus from P to F1 equal to constant. When P is on V1, you have F2P plus Pf1 equal to F2 V1 plus V1 F1. That is equal to F2 V1 plus V2 F2. You replace this term with this term from this expression. If we follow the order of the subscripts, we have V1 F2 plus F2 V2. V2 is already here. You have V1. Now F2 is common. F2 is common. So when you add this result from the concept of vector algebra, you have V1, V2 that is equal to 2A. Thus, F2P plus Pf1 is equal to 2A. The distance between F2 and P is expressed in this form. You know the distance between 2 points, this and this, is given by this formula. So considering F2 and P, we can take this S as S2, then minus C as S1, then Y as Y2, 0 as y1. If you replace them in this formula, you have this part. Then considering p and f1, if you replace them also, you have this other part equal to 2a. Considering p1, considering p and f1, you have s2, c is s1, y is y2, 0 is y1. It follows that let's transfer this term to the right hand side. You have it in this form. Square both sides. If you square this side, you have the result without the square root sign. Then you square the right hand side. If you simplify the right hand side, you have this result. From here, let's expand this term. If you expand this term, you have this result plus y squared equal to the right hand side. If you rearrange the previous result, some terms will cancel off and we are left with this result. From here now, the term that contains square root, let's move it to the left so that it becomes positive, and we transfer 2cs to the right. You have it in this form. If you add these two terms, you have minus 4cs. 4a can divide through. If you divide this term by 4a, you have this result remaining. You divide 4a squared by 4a, you have a. Divide this term by 4a. 4 cancel 4, you have cs over a. You have to square both sides again. When you do that, this result, the square root will disappear after squaring it, equal to the square on the right hand side. You come here and expand. You have this result plus y squared equal to, if you expand this term correctly, you have it in this form. From here, if we consider this term and this term, if you transfer anyone to the other side, it becomes positive and the sum is 0. So this term and this term, they are gone. We are left with this. From here, there is s squared here, there is s squared here. So let's transfer this term to the left. It becomes negative. Then we move out plus c squared to the right. It becomes negative also. Considering these two terms, s squared is common. You factor it out. You have this result and the other terms. You can write this term as over 1. When you find the LCM and simplify, you have these results and the other terms. Divide through by a squared minus c squared. If you divide this term by a squared minus c squared, it will remove this one. You are left with 1 over a square times s square. Divide this term by a square minus c square. You have it in this form. Divide this term by itself. You have 1. If you open this bracket, you have this result. Let's call it equation 12. From triangle OPF1, this point is C. By Pythagoras rule, a square is equal to b square plus c square. If you make b square the subject by transferring plus c square to the left hand side, you have equation 13. Substitute equation 13 into equation 12. In equation 12, this term is a square minus c square. You replace it with equation 13. You have b square in that position. In this form, a is greater than b. Equation 14. Equation 14 is the canonical or standard equation of an ellipse with the major axis horizontal. Similarly, if the major axis is vertical, it can be shown that s square over b square plus y square over a square is equal to 1. In this form, a is less than b. This form gives the equation of the ellipse with the following information. You have the foci f1 and f2. You have the vertices from v1 to v4. End of lesson 11. There is every need for you to be saved if you are not, because the Lord Jesus Christ is coming very soon. Some will be taken and some will be left. Live righteously and be prepared. Goodbye.